Hello, good morning. We're on to lesson 6 notes covering compound interest. Compound interest is actually based on word problems that have an exponential equation. It's also important and applicable in real life. If you ever get a loan or you get an investment with the bank, then often what you're either earning or getting charged is compound interest. Basically, that just means that the interest is calculated several times throughout the time you have your money in your investment so that your investment grows at an exponential rate, a lot quicker than if you just calculate interest at the end. You get interest added in at every interval, and then you can earn interest on top of that interest. So it follows our same regular equation for exponential functions, but it's a little bit different how we put it in. So first of all, you need to know a few different definitions. So number of compounding periods, that refers to the total number of times the interest will be deposited or withdrawn. So if you have an investment, you want it to be compounded more often because then you're earning interest more often. So if it's compounded annually, that means it's happening every 12 months or one time per year. If it's compounded semi-annually, that means you're getting your interest added in every 6 months, or in other words, twice per year. If it's compounded quarterly, that will mean you get your interest added in every 3 months, or 4 times per year. And then if it's compounded monthly, that means you're getting your interest added in 12 times per year each month. Okay, so let's see how this would work. We use our same formula, but now we need to kind of put in that extra information with it. Okay, so same kind of format, we just have to figure out what we have here. So Elise put $2,000 into an RRSP. So her starting amount is $2,000. She's earning 9.5% interest compounded semi-annually. This is talking about your B and your P value. So that means she has 100% of her money and she's getting an increase of 9.5%. So if you look up here, I put a generic kind of way to figure out your B. It's going to be 1, that's your 100%, that's your initial starting money, that always stays there, plus your interest rate divided by however many times per year it's actually occurring. So when I do my B down here, it's going to be 1 plus my interest rate, I'm going to write it as a decimal, divided by how it's compounded. It's compounded semi-annually, which means twice per year. So I'm going to divide it by 2. And that's going to be my B value. Then it says determine the accumulated amount after 7 years. So I want to know the total amount after 7 years. So my total time is 7 years. Your P value is how often the interest is getting put into your account, which is occurring every half year. So what you'll notice is whatever value you put here is your same value you're putting here. If it's semi-annually, it'll be 2 or over a half. Now we're just going to plug it into our equation. And then we can solve just like we've always done. We want to know the total amount after 7 years. Okay, so this is my formula. That's pretty straightforward, but it can be a bit tricky to put in your calculator. What I recommend, you can put it all in one step, but it's easy to make mistakes. So I'm going to simplify a bit first. We always do whatever's in brackets first. So be careful, this is 1 plus that fraction. So when you put it in your calculator, you should put brackets around this part in order to make sure you're not adding that 1 in first. You need to do the brackets there first. So when we put this in, we're going to have a 1 plus, in brackets, 0.095 divided by 2, close my bracket. So inside that set of brackets, it should be 1.0475. Then I have 7 divided by a half in brackets. Again, be careful with your brackets. Probably try doing this at the same time as me, making sure you're getting the same answers. Pause the video, make sure you know how to put it in your calculator properly. That's usually half the battle, is just putting it in. So now we have 7 divided by a half, which is going to be 14. So this is raised to the exponent 14. Now you can type it into your calculator to figure out what your y value is. So we have 2,000 in brackets 1.0475. And before I close the brackets, I'm going to do my exponent now of 14. Okay, and you can see the total amount's going to be $3,829.89. So again, practice that on your calculator as you go. Pause my video if you like, and make sure you know how to put it in correctly. So this basically tells me that this person, Elise, put $2,000 into a certain investment. After 7 years, she went to check her account balance. She now has $3,829. Okay, let's do another one. So we're going to look at Lloyd. So again, same thing, we're going to set up our equation. So it says Lloyd arranged a personal loan of $2,500. So he's getting a loan of $2,500. That's the starting amount of the loan. But of course, when you take a loan, when you pay it back, you have to pay back a little bit of interest. So you're going to have to pay back more than you borrowed. At 10.75% per annum, compounded quarterly. So this is your B value and your P value. So we have 1 plus the interest rate, written as a decimal, and then how it's compounded. Quarterly means 4 times per year. That's also going to be your P value, 1/4. He made no payments for 2 years. So he had the loan for a total amount of time of 2 years. We want to know what is the amount owing on the end of the loan after 2 years. So we have all our information there, we just have to put it into our formula. Okay, my A value, my B value, and 2/4. And be careful with this B value here, don't round it at all. You can round your final answer at the very end, but if you round too soon, your final answer is going to be off by a little bit. So I'll show you one more time how to put it in the calculator, and then keep going from there. So first I'm going to do whatever's in the brackets. So that's going to be a 1 plus, in brackets, 0.1075 divided by 4. So that's the number in the brackets. And again, don't round this value, store it or write it out. If you round it, your final answer will be off. And you have 2 divided by 1/4. You can do that in your calculator too, or you can start seeing the pattern there about 8, but let's do it in the calculator. 2 divided by, and in brackets, 1/4. You can see that equals 8. And then we can just type in that bottom line, 2,500, and in brackets, 1.026875, all to the exponent 8. And then close my brackets, and I can see it's going to be 3,090.87. So he took out a loan for $2,500. After 2 years, he's going to pay that person or the bank back $3,000, $3,090.87. So the next question says, how much interest was he charged for the 2 years? How much extra did he have to pay? So you're just going to subtract the 2. He ended up paying this much. His original loan was for $2,500. So you can see he ended up paying an extra $590.87 in interest. Okay, I'm going to do 2 more on the back page. Some aren't as straightforward. I might not ask you a final amount. I might ask you for something else. So let's look at the top one on the next page. So this one says, find the original RRSP investment if the final amount is $2,813. So just to make sure you're reading the questions carefully. So my final amount is this much. So that's going to be my Y value. It tells me it's a 6% interest rate, compounded semi-annually. Semi-annually means 2. So now I know my B and my P values. And my total time is for 2 years. Now I want to figure out my A is my initial amount. So plug in what you know. That's half the battle. Okay, and now I'm going to try and simplify as much as I can right off the bat because it makes my life a little bit easier with rearranging. So right away inside the brackets, I can do this part in my calculator and you should get 1.03. And when you go 2 divided by half in your calculator, you should get 4. Now if I want to figure out what a is, I just have to divide both sides by 1.03 to the exponent 4. Just be careful how you put this in. Again, I'll show you just this last step in the calculator. You're going to go 2813.77 divided by, use your brackets, 1.03, then do exponent 4, then close your brackets. Otherwise, your calculator, might get a bit confused, and it might raise the whole thing to the power 4 instead of just the 1.03. So make sure you do that. Pause for a second, type it in your calculator. Make sure you get this amount here. When I round this, for our money, it's going to end up being $2,500 in the end. So that's how much we would have started with to end up with $2,800 in the end. Okay, the next two questions are similar. We're looking for interest rate now, which is a little bit trickier. The trickiest one is the bottom one, so I'm going to do the bottom one. This one you can look at in the filled in copy of the notes. Okay, so we're going to fill in our information again with what we know. It says a $2,000 loan charges $389.66 in interest. So that means I'm starting with a $2,000 loan, and how much in total do I have to pay back at the end of the loan? It's going to be your $2,000 plus the interest you have to pay back. So that's going to give you $2,389.66 as your total amount you would have had to pay back. It says if the loan has a term of 2 years, so my total time is 2 years, and the interest is compounded quarterly. We want to know what is the interest rate. So from here, my B value, my interest rate is here. I'm going to call it R. So basically, I want to figure out what my R is. So now we're going to put it into our formula and see what we can do. Just 2 over a quarter. Okay, so the first thing that I did is I'm trying to isolate the R, so I've divided both sides by 2,000. Okay, so in your calculator, you're going to go 2,309.66 divided by 2,000. And I also know what this exponent is. 2 divided by a quarter is 8. So I'm going to write that. So I divided both sides by 2,000 to get to here. Okay, so here's the tricky part. This whole thing here is under the power of that exponent 8. So I need to get rid of that so I can get rid of the brackets and figure out what's going on. So in order to undo an exponent, basically I want to create this exponent to equal 1, because then I don't have to write it and it's gone. So you're going to try and think, what power can I raise it to so that it'll become a 1? Because if I do the same thing to both sides of the equation, it's okay. So if you raise both sides of this equation to the reciprocal of your exponent, because remember your rules, power to a power you multiply, so 8 times 1/8 is just a 1. It's going to cancel out that exponent. You can do this anytime you have something raised to an exponent. Raise both sides to the reciprocal of that exponent. So I have to do the same thing here in order to keep it equivalent. These are now going to cancel out. Technically, they're going to equal 1. And anything raised to the power 1, we don't have to write. So now on this side, I just have a 1 plus r over 4. And then here on this side, you're just going to type that into your calculator. Let's show that. So we have 1.198, 483, and we're raising it to the power of 1 over 8. Make sure you put brackets in. I think if you have a newer version of a calculator, you don't need to, but for your older ones, you definitely do. And I get this value here. Now, if you notice, that goes on forever. Those decimals go on forever. So you can either store your answer, or we can kind of keep going with our equation and not write it down yet, because I really don't want to round too far yet. So right now, I'm still going to write it this way, just so I remember, and I'm not going to round. Now let's keep isolating our r. So from here, I'm going to minus 1 from both sides. Let me get that. R is almost isolated, but now I have to multiply both sides by 4. And that's going to equal my R. Now I can type this whole fun thing into the calculator and get my R exactly without having to round any decimal values. So let's do that. So I have 4, and in brackets, 1.19483 to the exponent, and I'd probably put brackets, if you have a newer calculator, I don't think you need to. So I have that, take away 1. So be careful, all your brackets, maybe pause here, type that in, make sure you get the same answer as me. You should get 0.08999, etc. So we'll write that down. That's my answer, but we want to round my answer to the nearest 10th of a percent. So I'm going to multiply this by 100 to change it into a percent, and then I'm going to round to the nearest 10th. So it become 8.99%, but rounded to the nearest 10th, it ended up being 9.0% would be my interest rate. And that's the answer for that one. So a little bit trickier in the calculator, but make sure you practice them and you'll be good to go. That's it for today. Have a wonderful day.